kegiatan ini. Akhir kata kami ucapkan terima kasih dan semoga kegiatan ini bisa berjalan dengan baik dan lancar di kemudian hari dan selanjutnya. Terima kasih, thank you for your attention, dan Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Aan atas sambutannya. Acara selanjutnya adalah sedikit perkenalan dengan Ibu Profesor Suhana binti Muhammad Said. Beliau sekolah dari bachelor, master sampai doktoralnya semuanya di UK ya Bu ya.
Iya, betul.
Durham for bachelor and master education, and finally at Oxford University for doctoral studies. I wonder, apakah Ibu mau menambahkan tentang masa kecil Ibu yang mungkin bisa memotivasi atau memberi semangat kepada
Boleh.
banyak mahasiswa di
Terima
sini?
kasih. Boleh saya boleh tambah sedikit? Adakah terima kasih banyak Pak Nubalio dan terutama juga Pak Aan yang memberikan kata-kata aluan yang sangat baik sekali. Kami amat berbesar hati untuk turut serta dalam acara pagi ini bersama-sama staf dan juga pelajar Universitas Bengkulu. Pak Faizal juga ada di sini ya. Jadi terima kasih juga kepada beliau kerana menghubungkan kami untuk hadir pada pagi ini. Mungkin atas pelawaan Pak Navalio, saya terangkan sedikit daripada latar belakang saya lah. Saya memang berasal dari Kuala Lumpur, Malaysia. Pendidikan saya sehingga sekolah menengah atas adalah di Malaysia. Saya rasa yang menjadi sumber inspirasi saya daripada segi belajar sains, terutama sekali engineering dan fizik adalah arwah bapa saya. Kerana beliau juga merupakan seorang dosen lecturer fizik di Universiti Malaya. Jadi banyak daripada sewaktu kecil sudah didedahkan dengan buku-buku ataupun cerita-cerita berkaitan dengan sains. Jadi sangat memberi perangsang dan juga minat kepada saya adik-beradik untuk meneruskan pelajaran lah dan seterusnya sendiri menjadi lecturer di Universiti Malaya. So sedikit latar belakang. Jadi juga di dalam presentation saya pagi ini ada sedikit campur-campur walaupun saya daripada latar belakang electrical engineering di Faculty of Engineering. Research saya sendiri menghubungkan antara engineering, chemistry dan fizik. Saya takkan pergi terlalu dalam tetapi juga saya ingin sentuh sedikit kerana saya rasa penghubungan begitu dari segi multidisciplinary study banyak membantu dalam segi pengajaran, teaching dan juga penyelidikan. Jadi terima kasih Pak atas pelawaan untuk memperkenalkan diri. Saya sedia untuk memulakan lecture saya bila diperlukan. Terima kasih.
Terima kasih ya, Ibu Suhana. Itu tadi ungkapan yang singkat namun sangat menarik sekali. I hope that student will have more boost in their spirit and to learn more, especially learning not only engineering but also some physics or chemistry. Selanjutnya kita langsung saja ke acara yang utama, yaitu presentasi yang judulnya adalah Nanotechnology for Sustainable Energy. Profesor Suhana, time is yours.
Okay, thank you very much Pak Navalio. Mula-mula saya minta izinnya sebab slide disediakan dalam bahasa Inggeris. Jadi saya cuba campurlah antara English and also Malay. Juga sebagai introduction, this title of the talk, Nanotechnology for Sustainable Energy, is actually the title of my lecture course for final year graduate students at electrical engineering at UM. So it is an elective course where we want to convey to the students to appreciate the relationship between energy, which is a very important part in electrical engineering, but also to current global concerns for sustainability and how we can improve this technology by again relating it to nanotechnology. So you may have heard or maybe you have something in your courses related to nanotechnology, but what I try to do for my final year students who are interested in energy, I try to give them the perspective of sustainability together with nanotechnology. So that is the background of my talk today. Before I go into the subject matter, I just want to spend a few moments to introduce where I come from, University Malaya. We are in Kuala Lumpur. Specifically, I wish to introduce my department, which is the Department of Electrical Engineering. So part of the Faculty of Engineering, University Malaya. We are, yeah,
Rob,
yeah,
your slide seems to be
not moving.
not moving.
Okay, in that sense, can I not use slide share? Because sometimes when I use the display, then it may not show. Are you seeing it now? Boleh nampak?
Yes.
Electrical engineering. Mungkin saya perlu kekal begini ya.
Yeah.
Okay. Jadi saya teruskan, maksudnya for our Department of Electrical Engineering, kami antara nombor 56 in the QS World University Rankings. Kami satu jabatan yang sangat kecil sebenarnya. Lecturers, professors, associate professors and lecturers, senior lecturers are only about 30 people. We offer 3 programs. One we call Bachelor of Electrical Engineering, and as I will explain to you in the following slides, it's a very broad course. We have many elements from energy to communications to AI to control in this one course, because we want to give our students the flexibility regardless of which part of electrical engineering you would like to do. Following that, we also offer a Masters of Systems Engineering. This is Masters by coursework. We also have a Masters by Research, Masters of Engineering Science, and of course our PhD program, which has many international student participants as well. So as I explained just now, we are a very small department. We are 31 people. We are also required to actually be professionally active. So almost half of our staff are professional engineers. We have currently 1 international academic staff, and 85% of our academic staff have gained part of their degree abroad, the bachelor or the master or the PhD. So on average, per staff, for example, last year, each academic staff produces an average of 5 ISI papers. But I have to say that this is not equal. Of course, some people produce really a lot of publications and some maybe not as much, but our average is 5. I wish to then give you some kind of insight onto the kind of areas we have in electrical engineering, which then we actually convey to our students in our courses. So for example, I am under the power division. We have actually 7 people. So we have 3 full professors and 4 senior lecturers in this division. And below, I have put down the keywords. So even in power, we have a very broad range of expertise. I'm not sure in Bengkulu what kind of focus you have in your teaching or your staff. But for example, in our electrical power, we have the conventional ones such as power transmission, power generation. We also have professor studying high voltage, but in there they also incorporate some AI, machine learning materials, and also some energy conversion devices. This is myself and my colleague, Dr. Faiz. And then moving on, we have a division on electronics where they have IC design, reliability, and thin film electronics. We have another quite big division which works on industrial automation, which includes FPGA design, control of fuel cells, of electric vehicles. We have someone doing brain-computer interface. We have also embedded systems and image processing. And we have the biggest proportion are our staff from the communication sector actually. So in electrical engineering, half our people are doing communication, such as networking, optoelectronics, wireless, satellite, antenna, and so on. So that gives you the overview of what we do as a department. Just as a background as to where I am working in. So now I will give you some big concept of what my talk will be about. So the idea is I want to bring you on this from nanotechnology to sustainable energy systems. And I just thought that this quotation is quite suitable for starting this kind of topic, because we cannot solve our problems using the same thinking that we used when we created them. So, and I think when we say we create, as a society, we have created many issues as the society tries to progress. So we must change our thinking ways in order to tackle these new problems that come up, which is actually part of our own making as well. So we take, for example, the issue surrounding energy. As you know, there's a lot of issue concerning the burning of fossil fuel, from gas, from petroleum, which we use for everyday life, for the cars, for the factories, for the household. And of course, you are aware that now the whole world is driving to a better energy mix to incorporate more renewable energy resources, such as hydro, solar, biomass, and so on. But if you look at this graph that I have on this page, even the middle bar is for 2020, and the projection on the right is for 2035. And I can still show you that the proportion of pink is for oil, the blue is for natural gas, and the gray is for coal. 6% is nuclear here. So what I'm trying to show you, even though that the renewable part at the top of the stack is growing, the dominant energy resources in the world today and still growing is the fossil fuel, which again, people talk about how that leads to climate change, global warming, and so on. So the sustainability or the environmental concern in energy generation is a real and very big concern. So first, I want to put forward the problem, because as engineers, we always talk about problem solving. So one of the pertinent energy problems we have here is the energy problem. And in particular, how can we use the renewable energy to help us tackle this problem of oversupply and environmental problem due to fossil fuel burning. So here I would just want to snapshot on goal number 7 of the SDG, Sustainable Development Goal, where we want to aim to ensure access for affordable, reliable, sustainable, and modern energy for all. So apart from the fossil fuel, you may know, solar technologies is always being researched. Biomass, I'm sure in a country such as Indonesia, biomass is increasingly being used for energy as well. And the sources can come from many places, such as the waste from your palm oil plantation, or industrial residue, or animal residue. And we also, of course, have the hydropower coming from your water resource from the mountains and so on. Okay, so the next step is when we want to solve the energy problem. I like to look at it in 3 stages, depending on where you are as a researcher or as a scientist or as an engineer. Usually as engineers, we talk about systems. So for example, here we have a wind farm. So this is a system of a wind farm. It comprises of many mechanical and electrical systems. So this system will have a certain efficiency. If we go down one step lower, we talk about devices. So energy conversion devices such as solar cell. This device will also have a certain efficiency. Usually, systems are tackled by engineers. Devices are tackled both by scientists and engineers. If we go one step lower, we are going to be looking at the materials, the advanced materials that we need, for example, to make the solar cell or the materials for the wind farm. And usually we view this as the domain for the scientists. In the years that I have been working in research in renewable energy, I found that there is a limit as to what you can do for the systems or what you can do for the devices. And the big opportunity is actually at the materials, at the science level, which there can be a gap between the engineers and the scientists, and that's where nanotechnology comes in. But before I go into nanotechnology in detail, I just want to discuss a little bit more detail on the concept of sustainability and what it brings to the table when we talk about renewable energy. So there's many different ways that people define sustainability, but a definition that I like is the one I'm showing on this page, where sustainability is meeting the needs of the present without compromising the ability of future generations, which means that whatever we do today, we must ensure that the world remains a good place for our children and the children of our children. We are responsible for the world that we leave behind. So this can be the three pillars of sustainability. We always think the middle one, which is the environmental sustainability. But equally important is, for example, economic sustainability, because technology comes at a cost. So we must find kind of a compromise, for example, between the economic considerations and the environmental considerations. We also have social sustainability, for example, when we want to implement a certain policy. How is it going to affect the society? Is it going to be equitable? Is it going to safeguard the interests of the people? So those are the questions that will be raised when we discuss sustainability. Next, let's just go a bit deeper on sustainable energy concepts. We can also divide concepts in energy sustainability into four main angles. One is about the energy supply to meet growing human needs. As you know, the world population is growing exponentially. So how can we meet the demands of the society, the housing, the industry, the transportation, and so on? We also have number two is on the public health and safety. So, for example, people say that nuclear is, it gives a lot of energy supply, but of course we have to worry about the safety of such nuclear systems. We also have to worry that some of these energy actually can be toxic. So we have to consider, for example, biotoxicity. Next, we want to look at the protection of the biosphere, prevention of pollution. For example, people talk about turtles. Malaysia coastline has turtles and how they end up having many plastic on the coastline. We also have to look at energy efficiency and conservation so that we are not wasteful with the electricity that we use. So putting them together, I come back to solving the energy problem. As I said before, the bottleneck, personally, I see through my research, is that it is at the materials level. So this is where we are putting forward nanotechnology as a solution so that we get better efficiency or better performance for energy conversion. So I give you some example now. For example, you have solar cells. Yeah. So solar cells function on the basis that it's trying to absorb as much light as possible and convert it to electricity. So one way that nanotechnology can help this is that if you have a coating, if you see the orange balls on top of this solar cell, this is a coating of nanoparticles, very small powder, maybe aluminium. It could be something like aluminium or copper or gold. So the role of this nanoparticle is it tries to concentrate the light coming into the solar cell. So it gets more light coming into the solar cell. Therefore, in this case, nanotechnology can help as a solution for solar cells by increasing the light absorption in solar cells. I go to the next example. In particular, this is a technology that we at work on. This is called thermoelectrics, where we have a temperature gradient. You have one side of the device is hot, the other side is cold, and this temperature difference or the heat difference provides electricity. So one of the ways that we can improve the efficiency of such a device is we use nanomaterial in the middle as part of the thermoelectric material. So something we call nanowires is going to reduce the dissipation of heat inside the device and therefore increase its efficiency. Final example in this segment is the use of nanotechnology in fuel cells. We've all heard about electric cars. You see quite a fair number on the road these days. And subsequent to that, people are also talking about hydrogen cars, which are based on hydrogen fuel cells. So the idea of the hydrogen
Hilang. Ya, terputus ya.
Terputus koneksinya nampaknya.
Terputus ya, kita tunggu aja.
Okay, Pak. Can you hear me?
Yeah, now we can hear you again.
Oh, did you lose me for long?
Maybe half minute, something like that.
Half minute. Should I repeat something?
Yeah, you start with that
Where did I stop? Solar or thermoelectric?
fuel cell, I think.
Okay, no problem. Fuel cell is very little. I'm still on fuel cell. Okay,
Okay.
so I will repeat. Yeah, so the fuel cell, for example, we are talking about use of hydrogen.
The
You see me
slides,
again?
slide is not yet.
Not yet.
Yeah.
Shall I? Can
You
you see it now?
share screen again.
Okay, I should do that again. Just a minute. Okay, just a minute. Okay, can you see now?
Yes.
Okay, solving the energy problem, nanotechnology for hydrogen fuel cell, yeah?
Yes.
Okay, great. Thank you. So let me just recap this slide again. So we are talking about the use of hydrogen fuel cells for cars. So for example, instead of filling up your car tank with fuel, we are filling it up with hydrogen. So what happens in the fuel cell is that on the left-hand side, if you look at this diagram here on the bottom, the hydrogen enters the fuel cell and it hits the anode. Some catalysts will help this hydrogen oxidize to H plus, hydrogen ion. Okay? And this hydrogen ion will move inside the fuel cell to go to the cathode. When it reaches the cathode, it will combine with the oxygen coming from the other side of the fuel cell and will form water. Okay? So you get hydrogen gas being oxidized to H plus on the left-hand side and oxygen being reduced, O2 minus, and combined with the H plus to make water. What happens when H oxidizes to H plus is that it produces electrons, and these electrons flows outside of the fuel cell. This is the source of your electricity, which then runs the car. So what I'm trying to show here is, for example, the efficiency of such a fuel cell can be further improved if we can increase the oxidation, for example. And we can achieve that using catalysts on the anode and on the cathode. And nanotechnology helps us achieve better performance by using nanomaterials such as nanocatalysts so that the becomes better. So that's again another illustration of how nanotechnology can help us achieve higher performance for energy conversion technologies. So just a few more snapshots that I found interesting. I like to share with my students on the different types of technologies out there which are actually quite visionary. So for example, the concept of an artificial leaf, it is a device which tries to mimic the leaf, like artificial photosynthesis. So in this case, the device which mimics the leaf produces hydrogen, and its structure is as shown on this picture. The other example that I have is it's okay. I also have the antenna, but I believe it's not in the slide. What I will do next, for the next hopefully 10 minutes or so, if I have the time, is to give you the example of some case studies, and these case studies are coming from our research at So I'm going to go a little bit deeper on thermoelectrics, something we call spin crossover complexes, And then for number 3 and number 4, they are more on the system improvement. So once, excuse me. Sorry, I think I just lost you. Are you still seeing my screen?
Your screen is not moving.
Yeah.
Now it lost.
Yeah, let me do that again. Sorry, yeah, let me do that again. Okay. Right.
Right.
Can you see it now?
Case studies.
Okay, great. Yeah, that's right. Yeah, thank you. So number 3 and number 4 are about systems, which are a result of our research on the device side. Okay, so moving on. For example, we have thermoelectrics, which I mentioned briefly earlier, is the conversion of heat to electricity. Okay, and we get better performance. And this conversion of heat, for example, if we have this diagram on the left, is that we have a temperature gradient. We have a
Okay. Okay. I don't know. Profesor Suhana. Tes.
Sinyal Prof-nya mungkin, Pak.
Kayaknya. You should wait. We have lost audio. Ibu Suhana.
Saya coba hubungi beliau, masih ini.
Ya tolong Pak Aan.
Ibunya masih ada.
Sepertinya masih terkonek tapi apa? Hilang suaranya. Suara beliau. Menarik ini Bu Hera ya.
Please.
Iya, menarik ini.
Putus. Ibu Suhana. Prof Suhana, can you hear us? Baru mau masuk lagi.
Itu baru join lagi, Pak, Prof. Sananya, Pak.
Iya.
Jadi sudah diinfokan dari Prof. Faizul ke Prof. Suhananya. Dan ini.
Assalamualaikum, boleh dengar saya Pak?
Waalaikumsalam, Prof.
Ya, saya mohon maaf ya, saya tutup video mungkin itu dapat membantu. Saya pasang semula ya. Saya juga
Okay.
mohon kalau enable attendee screen sharing sebab sekarang saya tak dapat share.
Tak dapat share lagi. We can share all participants. Okay.
Let me try, ya. Boleh, sekarang boleh.
Yeah.
Oke.
Okey, kita sambung ya. Should I just carry on for the sake of time as well? Mungkin tak apa-apa, saya baru mula case tadi yang pertama.
Yeah.
I was talking about the thermoelectric energy, thermoelectric conversion technology, and I was introducing the application, which because this technology converts heat to electricity, and therefore it allows us to take any waste heat from industry, from cars, from homes, and so on, and make it into useful electricity. So ultimately, maybe this technology can even be connected to the grid for helpful electricity generation. So this is the point in my introduction, my self-introduction just now, that I said my own work, my research is a combination between engineering, physics, and chemistry. So I hope that, of course, the students can also maybe try to follow me. I try to make it very basic, but this is where I'm showing that the understanding of some chemistry or physics is very useful to make better technology. So for example here, different thermoelectric materials, they reach an optimum value at different temperatures. So for example, if you look at this slide, you have the material PBTE, which will function optimally at about 400 degrees Celsius. So this material, we try to match to the environment that has a lot of energy at 400 degrees Celsius, maybe like in the engine of a car. So the other approach that the scientists have found, and now it's been about 30 years, is that if you use nanotechnology, nanostructures, you can get better performance, much better than the bulk materials. So some examples of nanostructures are such as dots, nanowires, and super lattices. This is the background. So when we talk about the bottleneck that is to do with the performance of these thermoelectrics, it goes back to the material. So some of the material that Professor and I were looking at, in fact, was almost 10 years ago, is a class of materials called scaturodides. And to be quite frank, before we started researching this, we also had no knowledge of this material. So we had to learn about the material, what is its property. So we then found out that this material has a property because of its structure. It looks like a cage. So this cage allows good electrical conductivity to pass through the cage, but also have low thermal conductivity because of this big atom in the middle. So it's about designing the material based on our knowledge of the molecule. But this knowledge of the molecule will help us make better devices. So that's the angle. We try to make the connection between the molecule and the engineering performance. So what we did was we went through the periodic table, chose the formulation from literature that we thought would work as a good scaturrodite for energy conversion. So we came up with a table of possible materials like I'm showing you here. And I'm just going to show you two examples so that we don't drag it too long. But for example, we tried to add tellurium to a basic composition of La 0.5 CO4 sp12. Don't worry about it. What it just means is that we try to put in, we have a cage, we try to make a cage, and we try to put something in the middle, like we have here. And that something in the middle, we identified first to be tellurium. We tried to do that. We managed to do that experimentally with moderate success. So it depends on the choice of materials. But then what we did was we added another element to it. So instead of tellurium, we tried to put two things in the middle of the cage, two elements in the middle of the cage, which is lanthanum and indium. And we managed to get the structure that we wanted. So you have a cage surrounding the lanthanum and indium ion. And in this case, we very much succeeded to have a very big improvement in the thermoelectric performance. So this was a good indication. This is experimental results, good indication that we can actually use molecular knowledge to help us produce better energy conversion devices. So that's one of the case studies that I wanted to show you. And these are some of the papers that we produced along the line some years back. The other case study, the second case study I want to show you, still in the physics and chemistry intersection, is something that we call a spin crossover metal complex. Just by this class of materials, I learned from my collaborator. My collaborator was from the chemistry department, Dr. Nurbani Abdullah. And we have been using the materials for so many applications for the past 15 years. And at the end of the lecture, I will show you that this same material we have used for energy conversion, but we have also used for gas sensor. And I will show you the application right at the end. So for this material, we use them in liquid form. We use them in a solution. And why do we do that? It's the same concept that other energy conversion devices use, or energy storage. So for example, you are familiar with battery. In the battery, you may be aware that there is an electrolyte which helps us convert to electricity, for example, in a lithium-ion battery. So the function of the electrolyte is very important in battery. The same goes for the fuel cell, where also previously when I talked to you about the hydrogen fuel cell, the transport of the hydrogen ion in the fuel cell is enabled by an electrolyte solution. This is the one that is helping the fuel cell function. So again, there is a solution of ions inside the fuel cell, which is making the whole device function. We also have a class of solar cells, which we call DSSC, dye-sensitized solar cells, which again use electrolytes to help us convert sunlight into electricity. So the concept that we are using here is that we take the spin crossover material and we use them in electrolyte form so that we can convert heat into electricity, for example. This is just a nice animation which we did, because when I say we use this material, we design these materials too from a molecular level. I won't be going into that in this lecture, but I just want to show you that this is a real life simulation of the molecule which changes shape as we increase the temperature. So you can see just now, for example, that the molecule was quite long. And as the temperature increases, the molecule, it gets more compressed. So this is a temperature animation at the different temperatures, how the molecule actually moves in real life. Okay, so how can we use this information? Okay, we identify by changing, when we say we design this molecule, we can change the metal in the middle. We can change the length of this chain. We can also change its surroundings. And by changing all these things, we can change the shape of the molecule. And just by changing the shape of the molecule, we can increase the electricity that this material generates. That's the general story. And the amount of voltage or electrical voltage that this kind of material generates, the spin crossover material generates, is actually about 5 to 10 times higher your conventional semiconductor material. So what I'm trying to show here is that through some novel material which we have designed, which we have synthesized, it has the capability to make very high voltage material. Not high voltage as in the power transmission, but high voltage that can be used for power generation for smaller devices, like your wearable devices, for example. And we can play around with the formula in so many ways so that we get better and better voltage generation from these materials. Okay, so that's kind of the limit of what I'm going to be talking about in terms of the chemistry and the physics. Again, a number of papers which our team has produced, but we then try to put this kind of knowledge or material in semiconductor technology so that we can make semiconductor-based devices from them. Moving on, this is my third case study. This is about using sensors and also using AI to actually help us produce more biogas from palm waste. And I believe, of course, Indonesia has even more palm oil plantations compared to Malaysia, way more. And think about the waste. This waste, you may be familiar, is that in biogas plants, they collect the waste from the palm, put it in a lagoon or a tank to produce methane. And this methane is used as a fuel, as a biogas for electricity generation. So we had a project where we looked at using sensors and using AI to actually help produce more biogas and more efficient electricity generation systems from biogas. A final thing, a fourth case study, is to show you that from the material I spoke about earlier, the spin crossover material, in my second case study, we have actually used that same material to turn it into a gas sensor, CO2 sensor. Our students have taken this material, developed the sensor, and actually benchmark it against the commercial sensor, which you can buy online. For example, you can buy CO2 sensors online. And we showed that our sensor have an advantage over the commercial sensor because they have a low operation voltage. They are very selective. They can differentiate between CO2, ammonia, and so on. And they are very sensitive. So then we put them into an online monitoring system. And this is very useful for us in electrical engineering because I told you we have colleagues who do AI, colleagues who do communications. So we incorporate that into a system which we install in in one of the colleges in to actually monitor the air quality, the CO2 quality on campus. So that is taking you from the molecule to the device, which makes the sensor to the system, which is what I mentioned right at the beginning of my talk. So on this note, I end my talk to just give you a relationship between nanotechnology, sustainability considerations, and how we can make technologies which can have high performance and help us realize a more sustainable or a more renewable ecosystem for our daily life. So thank you very much for your attention. And I'd like to thank you very much to my collaborators as well. Thank you for your attention.
Thank you very much, Ahna. There was a very fast
I'm so sorry.
I think from material devices and systems.
That's right.
Yeah, I don't know how much we know about chemistry or physics. In my case, I think I should learn more about this to actually have deep understanding of whatever works you have shared with us this morning. Jadi tahapan selanjutnya adalah tahapan tanya jawab.
Boleh?
Boleh ya Bu ya.
Boleh.
Saya berharap kepada mahasiswa silakan ada yang mau bertanya. Students, if you want to ask something, can you raise your hand, something like that?
Ya, assalamualaikum. Hello, Alex. Ya.
Ya, Pak Alex.
Yes.
Okay, Pak Alex.
Thank you, Mr. Novel. And good morning, Professor.
Good morning.
How are you?
I'm fine, thank you, sir.
Okay. I am very interested with your material this morning.
Okay, thank you.
Because I also make some research about the have connection with your explanation just now. Now I also I make PLTU in Indonesia.
Boleh sila Pak. Sila Pak.
Halo,
Ya Pak,
Ya,
bahasa
ya, boleh,
Indonesia
Pak.
juga boleh.
Bahasa Indonesia aja Pak.
bahasa Indonesia, oke? Because saya
Boleh.
tidak bahasa Inggris, oke, baiklah.
Tidak maaf.
Sekarang saya sedang membuat penelitian di tentang PLTU, pembangkit listrik tenaga uap. Mungkin bisa dilihat saya sedang bekerja bersama mahasiswa ini. Kami sedang membuat suatu pembangkit. Bisa
Ya.
dilihat ini?
Belum nampak Pak. Oh, apa nih? Oh,
Gimana
sekarang nampak sedikit Pak.
Nampak sedikit. Coba tunjukkan ya.
Ini
Ini ada
pusing.
dengan pertanyaan saya Profesor. Saya tunjukkan. Oke. Apa? Ini yang saya tanyakan Profesor ya. Bagaimana ya membangkitkan kapasitas suatu solar cell, karena saya juga menggunakan solar cell ya. Sedangkan matahari kita ini begitu saja. Kita kan tidak bisa memperbesar atau memperkecil sinar matahari, ya.
Ya. Maksudnya tentang kapasitor ataupun battery storage system untuk menyimpan tenaga matahari sewaktu matahari tak ada.
Bukan, maksud saya begini, kan selama ini ya solar cell itu begitu-begitu saja. Kemampuannya mengolah listrik, mengolah sinar matahari menjadi listrik itu menurut saya masih kecil. Sehingga di Indonesia untuk membangkitkan listrik dan juga di Arab, saya lihat di Eropa itu mereka menggunakan daerah yang luas untuk membangkitkan energi listrik dari matahari. Saya pikir bagaimana caranya supaya kapasitasnya solar cell ini atau kemampuan dari solar cell ini harus ditingkatkan sehingga tidak perlu daerah yang luas seperti misalnya di Waduk Cirata tertutup semua, hampir sebagian besar tertutup hanya untuk membuat pembangkit dari matahari. Sedangkan kalau kita bandingkan dengan pembangkit lain, itu tidak perlu daerah yang luas. Jadi intinya bagaimana supaya berhubungan dengan kuliah Anda ini, bahan apa yang dipakai untuk membangkitkan kapasitas dari suatu solar cell, kemampuan untuk menghantarkan listriknya menjadi lebih besar. Thank you, Profesor.
Oke, terima kasih Prof. Maksudnya bagaimana kalau kita tingkatkan efisiensi solar cell itu sehingga kan kita tidak perlukan kawasan yang seluas yang dipakai sekarang.
Betul.
Ya benar, bagaimana meningkatkannya?
Itu kalau siapa yang boleh dapat jawab tu mungkin boleh jadi milioner ya Pak. Tapi yang saya nampak ada banyak, setiap tahun ada apa dipanggil performance ranking of cells. Jadi maksudnya ada setengah tu yang sudah komersial mungkin berdasarkan silikon dan sebagainya, tetapi ada juga yang masih belum fully commercial. Contohnya perovskite solar cell yang menunjukkan efisiensi yang agak tinggi ataupun plasmonic solar cell seperti yang saya ceritakan tadi yang dapat menangkap lebih banyak cahaya. Cuma sebab terlalu banyak teknologi, tak semua yang dikomersialise lagi berbanding silikon solar cell yang begitu banyak dipakai sekarang. Jadi maksudnya dia lebih kepada mungkin potensi jenis solar cell yang lebih high efficiency tetapi mungkin belum komersial lagi. Tapi saya percaya ada sebab ada yang mencecah mungkin 40% ke atas dari segi efisiensi berbanding yang mungkin yang sedang dipakai yang tidak mencacah efisiensi seperti itu. Tapi cabarannya lain, mungkin ada yang tidak berapa tahan lagi, mungkin yang tahan lifetime-nya pendek. Jadi perlu diperbaikilah dari segi R&D supaya nanti boleh dipakai di komersial.
Jadi boleh saya tanya lagi, Prof?
Boleh, Prof.
Jadi kan matahari kita tetap begitu-begitu saja matahari itu ya. Tidak bisa kita atur ya matahari kan.
Ya.
Jadi saya lihat itu adakah kemungkinan ya, kemungkinannya dari apa namanya, dari materialnya itu, dari material tadi itu bisa mempercepat lagi. Maksud saya tidak hanya menggunakan seperti yang apa namanya, silikon segala macam. Adakah material lain, Profesor? Maksud saya begitu.
Ada. Saya faham. Maksud saya tidak sebut secara khusus, tapi mungkin kalau Bapak pernah dengar contohnya perovskite material yang menjanjikan efisiensi yang agak tinggi. Cuma masalah dengan perovskite ni sekarangnya misalnya lifetime dia tidak stabil. Jadi tidak boleh tahan sampai 20 tahun seperti silikon. Jadi perkara itu perlu diperbaiki dari segi R&D supaya ia boleh bersaing dengan silikon. Sebab kita tak mahu nanti 2-3 tahun perlu diganti lagi.
Artinya contohnya, masih dalam pendidikan, Profesor, ya, belum
betul. Sudah dimulakan tapi banyak lagi isu. Dia lebih kepada stabilization. Kalau dikira dari yang dapat menangkap cahaya yang agak tinggi, perovskite juga boleh, dan juga seperti DSSC saya juga sebut dalam lecture tadi, dye sensitized, kosnya juga agak murah. Tapi mungkin dari segi berat, daripada leakage sebab menggunakan liquid dan sebagainya. Jadi biasalah sebagai engineer juga kita perlu ada pertimbangan trade off antara condition, real life conditions dengan theoretical performance yang itu kita perlu imbangkan. Okey. Artinya tidak lama lagi ya, Profesor ya. Jadi kita harap tidak lama lagi. Terlalu banyak penyelidikan dijalankan. Ya, terima kasih Profesor, terima kasih Pak Nopal.
Thank you. Terima kasih. Pak Alex is also one of lecturer in our department. If Professor. I see. Okay.
So, thank you very much.
Thank you. If there's one or two student who like to ask, ada yang mau bertanya dari mahasiswa? Apakah ada? Saya boleh bertanya, Ibu?
Boleh, sila Pak.
Di dalam konteks presentasinya, what is the biggest conversion ratio nowadays in solar cells?
Solar cells. Itu saya pun perlu semak juga kot. Maksudnya dari semua-semua yang diselidik sekarang.
Ya.
Okey.
Kalau Ibu. Kalau yang ekonomi, yang komersial masih di bawah 20% ya Bu ya. Yang
sekejap saya semak sebentar. Kalau untuk yang komersial sudah ada, saya sebut tadi perovskite, tapi dicampur juga dengan silikon. World record efficiency untuk itu adalah 3.9. Tapi yang lain-lain masih dalam 20 lebih.
Masih 20 lebih. Okay.
World record for perovskite silicon dalam 33. Yang eksperimental memang jauh lebih tinggi tetapi masih di experimental stage.
Okay.
Ada sampai mencapai 8. Kalau
after how many years do you think it will reach 40 something? 20 years or?
Kita lihat Prof. Kalau kita lihat, saya pun tak pasti perovskite dia punya gradient tahun ni bagaimana ya. Yang kita nampak, kalau tak silap saya, dalam julat 20 tahun ada dalam penaikan dalam berbelas persen. Jadi kalau Indonesia belasan persen, jadi mungkin kalau kita mau lihat dalam 10 tahun, saya tidak pasti, but of course technology is not linear. Agak susah untuk saya duga, mungkin 5 hingga 10 tahun, tapi saya dapat menjanjikan.
How about another one is hydrogen fuel cells.
Fuel cell, yeah.
How long does it take? How long will it take to become? We have a hydrogen car. How long will it take for us to?
Hydrogen car.
Yeah.
Frankly, saya rasa itu Pak Faizul lebih arif untuk menjawab, lebih kepada mechanical engineering.
Okay.
Yang saya nampak mungkin daripada declaration daripada industri, ya, misalnya Toyota sudah mula mengumumkan, di Eropah juga ada yang mula mengumumkan bahawa mereka sudah ada. Jadi untuk menjadi commercial tu saya sendiri kurang arif, saya minta maaf.
Oke, saya berharap ada mahasiswa atau mahasiswi yang bertanya, atau kita tunggu.
Sambil selingan Pak Nopal, bisa Pak Nopal?
Boleh sambil menunggu mahasiswa, boleh Pak.
Ya, sambil menunggu mahasiswa. Profesor, saya salut tuh sama Malaysia, Profesor.
Boleh. Silakan.
Saya salut sama negara Anda tuh, Prof. Karena karena negara Anda sudah bikin mobil, Prof, bikin proton masuk sampai
bikin proton
Indonesia.
Masya Allah. You have proton. We don't have national
We have
car.
proton.
Yeah.
Your market is very big. Sekiranya.
Our market is very big, but we don't have our own car. We have Toyota, Honda, so many cars, but no Indonesian car. Yeah.
Nanti insya Allah bersama Universitas Bengkulu juga mungkin ada pembangunannya.
Amin.
Mungkin dengan
Amin.
Insya Allah. Amin.
Okay, how about Sela, are you asking or not? You have some question? Mutasa, maybe? Najibul? Randy?
Yes,
Febrian? Silakan. Siapa yang mau?
Ya, silakan.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Sebelumnya saya ucapkan terima kasih atas materi yang telah dipaparkan oleh Profesor Suhana dan kesempatan yang diberikan oleh para dosen teknik elektro dalam memberikan kuliah umum ini. Jadi saya ingin bertanya, tadi kan Profesor sudah menjelaskan tentang konsep energy sustainable. Ada salah satu poin yang saya baca tadi adalah energy efficiency and conservation. Jadi mengenai energy efficiency dan conservation ini saya ada melihat suatu riset ataupun suatu penelitian itu yang mengatakan bahwa setiap tahun permintaan energi di suatu negara itu akan semakin meningkat atau setiap tahunnya permintaan energi itu akan semakin meningkat. Nah, hal ini menjadi tantangan dalam menerapkan kebijakan konservasi energi di tengah permintaan energi yang semakin meningkat. Nah, jadi dalam menghadapi hal ini, saya ingin bertanya, apa biasanya solusi dalam mengoptimalkan energi efisiensi dan conservation ini? Terima kasih, Prof.
Okey, terima kasih Randy ya. Saya rasa ini mungkin perlu solusi dari beberapa peringkat. Contohnya kalau kita ambil dari segi systems, energy efficiency kita sudah ada, maksudnya kalau dalam bangunan, building management system yang menggunakan artificial intelligence yang boleh mengawal penggunaan elektrik untuk lampu, untuk kipas, air conditioning dan sebagainya bergantung kepada keberadaan orang dalam bangunan tersebut atau dalam sesuatu bilik, for example, that will help with the energy efficiency. On the electrical transmission ataupun usage side, that can also be monitored. Maksudnya juga ada sistem yang boleh mengawal penggunaan elektrik. Jadi bersama-sama mungkin sedikit dari aspek yang berlainan, bila digunakan bersama akan mengambil efek yang agak besar untuk mengurangkan penggunaan elektrik. Sekiranya itu yang saya faham daripada soalan tadi.
Oke, bagaimana Randy?
Boleh Randy? Itu.
Oh, jadi untuk mengoptimalkan energi efisiensi ini mungkin dari segi sistemnya aja ya, Prof. Ataukah dari segi lainnya itu apakah masih ada gitu?
Ada juga, maksudnya daripada segi device juga kita boleh ada peranti ataupun energy conversion yang tak memerlukan banyak activation energy. Contohnya seperti dalam case tadi keempat saya tadi, di mana kita ada sensor, dan sensor ni kalau kita tahu banyak digunakan dalam control system sebagainya, even for building management systems, di mana jika activation energinya rendah maka electricity consumptionnya juga lebih rendah. Itu satu contoh. And of course, you can also go to, it can be system, it can be material, but you can have things like passive elements. Maksudnya, instead of using air conditioning to cool houses like in Indonesia or Malaysia, you can use passive cooling systems yang tidak menggunakan tenaga elektrik. Jadi tak semua pada saya semestinya has to be electrical technology or high technology or nanotechnology. Even though I was talking about nanotechnology, sometimes the solution can be very, very simple. Dan lebih kepada architecture, misalnya architecture di Nusantara dan sebagainya. Perlu bergabung sekali. Okay, Randy.
Okay, Randy.
Baik, terima kasih Prof dan
Ya,
Pak Noval
sebab
atas jawabannya.
Okay,
Terima
yeah.
kasih.
As a technology people, we have to also mengerti bahwa kadang-kadang teknologi bukan satu-satunya solusi.
Betul.
Gitu. Kadang-kala juga
Sometimes it's
perubahan
simple.
behavior change also needed, especially in energy consumption. We have problem actually also in the people part.
Betul.
Manusia seringkali penyumbang utama pemborosan energi seringkali.
Betul, Pak.
How about the other students? Ada lagi mau bertanya? Di sini ada Mas Ayu, ada Muhammad Arfan, ada Galang, Gifari. Ada yang Gifari mau bertanya? Tidak. Kadafi?
Pelajar tahun berapa nih, Pak?
Kita punya
Rata-rata.
dari semester first, second, and third year student are here actually. Yeah, fourth year student also here. Andre, ada pertanyaan Andre? Andre tidak. Najibul?
Tidak, Pak.
Tidak. Well, I don't know then. Maybe since there are no more questions, we may indeed end this session. I hope that our head of department, Ibu Hera, would like to say some closing remarks before we actually finish this. Ibu Hera.
Oh ya, terima kasih Pak Noval. Assalamualaikum untuk Prof. Hana.
Waalaikumsalam.
Ya, terima kasih atas ya Prof. Terima kasih atas kehadirannya.
Putus-putus ya.
Di Zoom ini. Dengar Bu? Bu
Maaf,
Hana?
Bu, jadi
Ya?
kurang, putus-putus. Saya tutup video saya juga.
Ya?
Ya, putus-putus. Tak apa, sekarang boleh.
Iya, oke. Terima kasih. Terima kasih yang sebesar-besarnya kami haturkan untuk Prof. Suhana yang sudah memberikan materi kepada kami di Fakultas Teknik, terutama terkhusus di bidang di prodi kami di Teknik Elektro. Materi yang diberikan sangat relevan dengan beberapa mata kuliah yang ada di program studi teknik elektro Fakultas Teknik Universitas Bengkulu ini. Di antaranya mungkin konversi energi, gitu Bu, elektronika daya dan material elektrik. Mungkin itu sangat-sangat berkaitan erat dengan materi yang diberikan oleh Prof. Suhana. Mungkin itu saja, Prof. Penyampaian dari kami. Sekali lagi kami ucapkan terima kasih yang sebesar-besarnya atas materi yang diberikan. Mungkin itu saja. Saya serahkan kembali ke Pak Noval. Terima kasih Pak Noval.
Terima kasih Bu Hera. Terima kasih juga kembali kerana peluang menjemput kami dan semoga insya-Allah hubungan antara UM dan Universitas Bengkulu juga dapat dilanjutkan insya-Allah.
Inshallah. So, Professor Suhana, we have reached the end part of our session today. I am, as a moderator, would like to thank you again. Atas lebih kurangnya ada khilaf, kami minta maaf, Ibu. Apabila di masa depan Ibu berkenan bisa berkunjung ke sini, atau mungkin kami berkesempatan ingin juga ke University of Malaya.
InsyaAllah, silakan, kami mengalu-alu.
Oke, kita akan mengakhiri acara kita dengan sebutkan tahmid lah ya. Alhamdulillahirabbil alamin.
Alhamdulillahirrahmanirrahim.
Nopal, sebelumnya bisa kita foto bareng dulu.
Oh iya, tentunya sebelum terakhir kita harus foto bareng. Mohon videonya diaktifkan semua peserta.
Pak Fahrul bisa handle foto bersama.
Ini berapa halaman ini? Mohon aktifkan semuanya kamera dan tersenyum. Fahrul, ready?
Ya, Pak.
Ya.
Ada 4 slide di sini. Kita mulai dari slide pertama. Di slide pertama ini masih belum banyak yang on cam. Bapak.
Andi Kurniawan, tolong kameranya.
Sudah saya like juga. Oke, untuk
jadi Ahmad Fadil, Renhat.
Mantap Pak Alek.
Alhamdulillah.
Kita mulai ya. Untuk slide pertama ada timnya Prof. Suhana dan teman-teman. Kita mulai. 1, 2, 3. Oke, selanjutnya slide kedua. Slide kedua, 1, 2.
Terus?
Oke, selanjutnya slide ketiga. Slide ketiga ini belum banyak yang on cam, silakan.
Charles, Raffi, Fadila, Hilda.
Kita mulai ya, 1, 2, 3. Selanjutnya slide keempat terakhir. Silakan di on cam, yang belum on cam nomor 1, 2, 3. Oke, finish Pak Nopal.
Okay, everyone, that was very good session today. I am thanking you very much again, and I hope to see Professor Suhana in the future, either here in Bengkulu or in Kuala Lumpur.
InsyaAllah Pak.
Insyaallah.
Terima kasih banyak semua. Universitas Bengkulu insyaAllah jumpa lagi.
Amin. Terima kasih Prof.
Thank you,
Terima kasih
Prof.
banyak.
Oke,
Okay, thank you.
billahi taufiq wal
Assalamualaikum.
hidayah. Waalaikumsalam warahmatullahi wabarakatuh. See you again, everyone.
Insyaallah. Assalamualaikum.
Warahmatullahi wabarakatuh. Waalaikumsalam.
Oke. Terima kasih Pak Nopal, Bu Hera, dan Pak Farul.
Terima kasih
Oke,
Pak
terima
An.
kasih Pak An.
Semuanya, terima kasih.
Di elektro
Izin.
sudah berlangsung.
Alhamdulillah lancar.
Selesai.
Pak Alex semuanya ya yang hadir. Saya izin duluan live ini, Pak An.
Ya Pak.
Nah,
Oke.
yuk semuanya.
Sama izin, please.